All right, so we're moving on from yesterday to Descartes' rule of signs. I talked yesterday, Rene Descartes. The college kids thought it was funny that people thought he was, never mind, we won't go there. Anyway, Rene Descartes is a French mathematician, and he came up with the Cartesian coordinate plane. Cartesian coordinate plane. In high school, we call that the XY. I don't know why they dummy down things for high school. They should do it the other way. Anyway, the Cartesian plane. And he also said, I think, therefore I am. Anybody look that up? I think, therefore I am. That's a mathematical symbol he actually used. 3 dots means therefore. So, anyway, Descartes' rule of signs. If you have a polynomial, say f of x, equals x squared plus 4x plus 1. We know there are 2 zeros that make that 2 x values that make it equal to 0. Okay? Descartes, who was a mathematician and somewhat of a scientist and a philosopher, said that if you look at the number of sign changes from each term, a sign change counts from positive to negative or from negative to positive. Positive to negative or negative to positive, that counts as a sign change. If you count the number of sign changes, that will tell you how many positive roots at most it can be. If I look, there's a plus sign right here. There is no positive sign changes. Descartes proved that there are no x's that are positive that would make f of x equal to 0. There are no positive x values that make y equal to 0 because there aren't any sign changes. He also said that if you put a negative x in, let's say it's f of negative x. What is negative x if you put it in for this and you square it? What do you get out? X squared. If you put in a negative x here and multiply it by 4, what do you get? Negative 4x. And this is where people say, I'm confused, I don't know what. All I'm doing is I'm putting in negative x for all the x's and seeing what comes out. It's the first thing you do for checking even and odd functions for symmetry. Y-axis and origin symmetry. If I put negative x in for 1, what's it come out to equal? 1. If you put negative x in for 1, it's not going to change it. There's no variable, so it's just going to equal 1. It's known as a constant. It doesn't change regardless of what number you put in for x. So, now how many sign changes are there? 1 here and 1 here make 2. Descartes theorized there could be 2 negative x's that make it equal to 0 or no x's, negative x's that make it equal to 0. You always have to account for the possibility of things below the highest number of sign change. For instance, Descartes said, if you had, let's say, 5 for f of x, if you have 5 sign changes for the positive x's, you could have 5 positive zeros, 3 positive zeros, or 1 positive 0 that makes it equal to 0. If you have f of negative x, and you have like 6 sign changes, you could have 6, 4. You have to account for all the possibilities down to nothing. Okay? You have to account for all those sign changes. And how do you know how many zeros there are in a polynomial? The degree. The degree of the polynomial. That's what tells you how many zeros there are. Okay? Now, let's just worry about the sign changes first. On this one, f of x equals 3x cubed minus 4x squared plus 3x plus 7. What does f of negative x look like? If I put negative x in, I get negative 3x cubed. For some people, this is a challenge enough. If I put negative x in and I square it, multiply by 4, what do you get? Negative 4x squared. If I put negative x in and multiply by 3, what do I get? And negative x in for 7, what do I get? Plus 7. Okay? Now I can count the sign changes for the positive x's. For the positive. How many sign changes are there? 1, 2. From positive to negative, negative to positive is 2 sign changes, right? So the positive x's that can make it equal 0 are 2 and 0, right? I could have 2 x's that make it equal 0, or I could have no x's that make it equal 0. So far, so good? Let's count the negatives now. How many negative sign changes are there? 1. Negative x's that make it equal 0, there's only 1. I can't put a 0 there because it's an odd number. In this case, 0 is considered to be even. That's the only possibility. To answer the question that's being asked, you have to list the positive and the negative solutions. I could have 2 positives, or I could have 1 negative, right? Does that make sense? Or I could have 0 positives and 1 negative. Does that make sense? Those are my possibilities. Now the question comes in, how many total zeros are there for this polynomial? 3. Each row has to equal the number of solutions. 2 plus 1 is 3. That's good. That checks. 0 plus 1 doesn't equal 3, though. What would the other 2 roots have to be? Not 0. Imaginary. Did you know that imaginary roots always come in pairs? 2. Actually, I'd put NC for non-real complex, but that's beside the point. So, for this answer, you're guaranteed if you graph it out, it will cross the x-axis one place on the negative side. You're guaranteed there's one negative x value that makes it equal 0 that you will see. That's what Descartes' rule sign says. Okay? And that's how you answer the question. Your little chart. That comes from your this. Now, most people don't physically write this out. They know it, they read it, they use it. But you guys are just starting out in this game, so, you know, it's probably a review, but we're going through it again. Let's try another one. So when you're thinking about this, you know, when you're thinking happy thoughts, you're thinking that f of x equals 2x to the 4th minus x cubed plus x squared minus 3x plus 4. How many sign changes are there in that polynomial? I'll give you a minute to write this down. How many? Are there 4? 1, 2, 3, 4. So for positive x's that make y equals 0, I could have 4 of them, I could have 2 of them, or I could have 0 of them. You always start and work your way down at the highest one. There could be 4, there could be 2, or there could be none. For the negative x's, again, most people just think this, but we're just starting out. If I put negative into the 4th power, it'll come out positive, won't it? 2x to the 4th. If I put negative in here and cube it, it'll come out negative x cubed. I'm subtracting it. Positive x cubed. I put it negative, oh, plus x squared. That's easy. Even powers are easy. They don't change. Plus 3x plus 4. So there's not going to be any x values that are negative that will make that equal to 0. That's Descartes' rule of sign. So if you're going to graph something out, go to the positive x side and see what happens. So there's going to be 0. Yeah. So P and C. I can have 4 positives, 0 negatives. What's the order of the polynomial? Yeah, order of degree is the same thing as 4. That adds up to 4, doesn't it? So we're in good shape. Or I could have 2 positives. How many negatives can I have? 0. And how many non-real complex? 2. That makes 4. And finally, I could have no positives, no negatives, and 4. So if you say there's no place this graph crosses the x-axis, I would believe you. If you say there's 2 places, I would believe you. If you say that -1 is a solution, I'd say, no, you're not. It happens all the time. I give people a problem to graph out. They graph it out, and they say, I got -1. I said, you can't. How did you know? How did you do the problem so fast? I didn't do the problem. I just looked at it. I know there's not going to be a negative answer for that problem. Just Descartes' rule of signs. Positive, 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 positive. It's not going to happen. That's how people use it most often. Or teachers like me use it like this. People that are gone, absent, or whatever, this used to be question number 1 on the old exam I gave. It said find all the real zeros of the polynomial. It said find all the real zeros of this polynomial. I still remember to this day. So f of x equaled 1071 x to the 8th plus 435 x to the 6th plus e x to the 4th plus pi x squared plus 10. I said find all the real zeros. And what do you think kids are going to do that don't pay attention to what I just talked about? What do you think their reaction is going to be?
Complain.
Oh, I got to go see him right away. And then the line forms at my desk. So I can see all the people that don't pay attention to what I say. They're lined up. There aren't any real zeros. How many sign changes are there for the positives? None. How many are there for the negatives? None. And you know why you should tell them? Well, be gone and go try your best. So you punch down the calculator. Aren't going to see anything. I've already taken them up to 1,071. Oh. And then they got to figure out how to type this in. What is that? Well, what do you want it to be? I don't care. Well, then frustration sets in. And that's on question number 1. How do you think they did on the rest of it? Down the tube they went. Why? I still do. Exactly. Oh, I still do. And you'd be surprised how many people don't. Oh, any problems out of section 37 you can omit? Any problems out of section 37 involving number 37 you can omit? Like 35 through what? There you go. Sounds good. Find the factored form of the polynomial. How are we doing? Oh, we got, what, 2 minutes? Okay, good. Find a factor form of a polynomial that has minimal degree. That means the smallest that's possible. Assume the intercepts are integers and x and y scale. Kind of like what we did earlier in the homework check. For this one, this crosses at -2, this crosses at -1, this crosses at 2, and this crosses at 0, 1. So to find the polynomial, it's fine if you just list the factors and what a equals. Okay? So what would the factors be? X plus 1, x minus 2. Am I missing anything? Okay, am I missing anything else? I think one of them is, I think this is squared, isn't it? Because it doesn't actually cross, it's tangent. So this goes to a second degree. Hence the parabola. All right. So now I think I'm ready to find out what A is. G, because they dummy it down anymore, 0 and 1. 2. All right, Andrew, see if you can do this one if you're listening. 2, 1, 4, A equals 1. So what's A going to equal? 1/8. So A will equal 1/8. In fact, I think I actually gave this one as a homework check to my 5th hour, and people missed it.
No.
I couldn't believe it. Well, yeah, they don't write down notes. Yeah, because I'm using this point to find out what A is. Okay? Let's see. So the answer would be f of x equals 1/8 times x plus 2, x plus 1, x minus 2 squared. So far, so good? Fantastic. I think we're about done. Yeah, you graph that one out and give it a go. That one you just check it out with the zeros. You find A and see if it works. It looks a lot harder than it really is. X minus 2, X minus 5.2, and X minus 10.1. You put this number in for X and see if you get that number out for Y. It's not very difficult because you have a graphing calculator. Shell?
You said we don't have to expand variables,
Right.
right?
Now for this one, you graph it out, start with synthetic division, you're on your way. All right, I think that takes care of everything. Oh, should we go through a rapid fire?
Yeah.
We gotta do the.
I don't know. How far is it, Megan? What do you mean you don't know? Page, what is it?
You want to do what?
Yeah, 1 or 2.
What's the last one you showed us?
58.
No,
Keep going.
no, we'll go to 53. I don't know. Do you have your book open? 238. What?
240.
Yeah, whatever the 53 odd. 27 to 53 odd. Okay. All right, we'll do a rapid fire, then we'll get to our 5 for 10. Oh, I should do this so that Drew and all them can do it with us. Ready? Everybody's going to do really good on this one.
Is it the same one?
I just mixed up the slides. What? Practice helps. Practice helps. Ready? Here we go. See how many you can do? All right. On your mark. Get set. Go.
Stairway to
Nice. Quadratic, I'm sure you got that one. Cubic, square root, linear, absolute value, sine or cosine, piecewise, and the greatest integer function. Which one? The greatest integer function. See, you can be like a cartoon character. Nice.
I got it all. I got them all right except for 7.
4 and.
All right, good. Hopefully everybody did well. Now we're going to do our
Right.
10 for 20. 20 for 30.
10 for 100.
All right.
They were all off, but I did that.
We're on page 225. And we'll do numbers, I don't know, this is a piece of cake. That's too easy. Okay, 3, 16, 25, 40. Oh, that's easy. And finally, the last one, 40. I don't know, 40, 41. 41. All right, there you go. Oh, I gotta stop the recording.